All right, let's jump right in. Have you ever wondered how your phone, your computer, how anything makes a simple yes or no decision? You know, predicting something that only has two possible outcomes? Well, today we are cracking the code on one of the most essential tools in data science that does exactly that: logistic regression.
Think about it like this. A student studies for a few hours. Based on that, are they going to pass the exam or are they going to fail? It's a classic yes or no question, right? Or hey, how about this? A customer is browsing your website, they've clicked on a few things. Are they actually going to buy something or just leave? Another simple choice. And here's one you and I see literally every single day. An email hits your inbox. Is it junk or is it something you actually need to read? A decision has to be made, and it's got to be instant. So, all of these things, pass or fail, buy or don't buy, spam or not spam, they're all just different flavors of the exact same challenge. It's what we call the yes or no problem. Now, the kind of technical term for this is a binary problem, and binary is just a fancy word that means two parts. The answer can only be one of two things. There's no gray area. It's either a yes or a no, a 1 or a 0, true or false. That's it. Now, you might be thinking, okay, this sounds pretty straightforward. Can't we just, I don't know, draw a line to separate the yeses from the nos? And that is a great thought. But as it turns out, that leads us to a really interesting problem. So yeah, the obvious question is, why can't we just use a method we already know? Something like linear regression. I mean, it's great for predicting numbers, so why wouldn't it work for predicting a simple 0 or 1? Well, here's the catch. A straight line, which is what linear regression uses, it doesn't play by the rules of probability. It might predict a value of, say, 1.4. But what on earth does that mean? You can't have a 140% chance of something happening. Or even worse, it might predict negative zero point 0.6. A negative probability? That's just impossible. It doesn't make any sense. So here's the bottom line. A simple, straight line just completely breaks when you try to apply it to a yes-no problem. It gives us answers that are pure nonsense in the real world. We need a smarter tool, something built for this exact job. So, if a straight line is a no-go, what does work? Well, this is where our hero comes in: logistic regression. And it uses this really elegant two-step solution that's perfect for these binary problems. Let's break down how it works. Okay, so instead of jumping straight to a yes or no, logistic regression does something way smarter. First, it calculates the probability. It might say, there's an 82% chance this student will pass. Then, and only then, does it take that number and use a simple rule, like, hey, if it's over 50%, let's call it a yes, to make the final call. And this is so much more useful. Knowing there's an 82% chance of passing tells you how confident the prediction is. It lets you make better decisions, way better than just a blind "you will pass" with no context at all. So the big question is, how does it do that? How does it generate that perfectly behaved probability every time? Well, it has a secret weapon at its core, something I like to call the magic S-curve. Here's the secret sauce. First, it takes all the info it has, like the hours a student studied, and it calculates this internal score. We'll just call it Z. And this Z-score can be any number: big, small, positive, negative, whatever. Then it takes that Z-score and feeds it into a special function to get our probability. And that special function is called the sigmoid function. Honestly, this thing is the absolute heart of logistic regression. It has one job, and one job only: to take any number you throw at it and neatly squish it into a value somewhere between 0 and 1. It's basically a probability machine. Now, the formula might look a little intense at first, I get it, but don't worry about memorizing it. What's really important isn't the math inside, but what it does. And what it does is just beautifully simple. Just check this out. If you give the sigmoid a big negative number, like -5, it spits out a number super close to 0. See? About 0.01. If you give it 0, it gives you exactly 0.5, a perfect 50-50 toss-up. And if you give it a big positive number, like 5, you get a number that's almost 1, like 0.99. It's the perfect tool for turning any score into a sensible probability. Okay, theory time is over. We've seen all the individual pieces of the puzzle. Now, let's put them all together and solve a real case from start to finish. Let's go back to our student. Step 1. We know they studied for 7 hours. Step 2, our model, which has already learned some patterns, calculates that score. Let's say its formula is z equals -5 plus 1 times the hour studied. So for 7 hours, our z-score is 2. Step 3, we pop that score of 2 into our magic sigmoid function, and out comes a probability of about 0.88, so an 88% chance. And finally, step 4, since 88% is way bigger than our 50% cutoff, the final decision is pass. See? Simple as that.
And there you have it. That's pretty much logistic regression in a nutshell. It's this super clever, really powerful technique for answering some of the most common questions you'll find in the world of data.
And trust me, this is used everywhere. In marketing, to figure out if you're going to buy something. In banking, to see if a loan is too risky. And even in medicine, to help doctors estimate the odds that a patient has a certain disease based on their symptoms. It's incredibly useful.
So if you're going to take away just one thing today, let it be this. Logistic regression is a two-step dance. First, it predicts the probability of a yes-no outcome using that clever sigmoid function. Then, it turns that probability into a final, clean decision.
And that's our deep dive. So now that you know the secret to cracking that yes or no code, here's a question for you. What binary problem, what yes or no question in your world, your work, or your life could this awesome tool help you answer? Think about it.